Hello everyone, I'm Bob, and I'm going to be going over some Meshtastic radios. A few years ago, I started getting into low road communications. It's a fascinating field. It's now technically Amazon Sidewalk, the largest mesh network in the world. These things span. They've covered entire cities, and it can do a whole lot more than people think. I got into them specifically Meshtastic because if you go out and backpack or you hike or anything like that, these communication devices and off-grid devices, they're very expensive. And I thought it'd be fun to just, look into ones that had already been made. And the creator of Meshtastic actually is a paraglider. And they would get separated in the forest. And they wanted to be able to find each other without having these subscription systems or anything like that. So that's the kind of the origins of where it began for the original creator. I mean, there's tons of ESP32 based low-res systems that are out there. Meshtastic just seems to be the one that gained enough momentum that it's really come a long way over the years. So originally, everything was done with your computer. It's Python and not Python, and it's a mix mash of things. And then they had an Android app, and now they have an iPhone app, and it looks great, works great. So it's come a long way, and it's all community driven. And there's lots of different options when it comes to Meshtastic. So if we take a look, this is their repository on GitHub, of course, where everything as far as firmware and code is going to be. But they also have their website. So there's a meshtastic.org, which is the official website, and then there's also an unofficial website where there's still forums and people talk about things and things like that. But you want to go to meshtastic.org to get started. And you can literally hit get started here, and it'll take you through a pretty good, I think, for the most part, it's decent enough, but there's still quite a few people that have some issues figuring out, how to get started with these things. Because maybe they had an older one, or they get one and they can't get it to flash. Because the system, it's come a long enough way that there's now some public resources available, like a web-based flasher, which is, actually really nice. If you look here, it'll tell you, you can get your different versions. I am using the T-Beam. This is the T-Beam. This can operate on pretty much any lower spectrum in the globe. You do have to set your region. That is important. You don't want to be breaking region rules because different spectrums do different things, especially here in America. It is important to read where you can use these things, because I believe Colorado and Wyoming, they're not allowed. So just read up on them. In general, these devices, you don't need a radio operator license. If you do have a radio operator license, you can broadcast up to 3 watts on these things, and then the range is insane with that. But for your standard user and the standard settings, this right here is going to be, for most general use cases. Now, if you are a ham radio operator and you do have your license, they do have base station models that are meant for 3-watt output, and you can set it up as a gateway if you wanted, and you can allow public access, because there's tons of scientific projects that you can do that maybe you want to make a public gateway with one of these things for other projects, or maybe you have your own mesh you want to create. So that's what I'm kind of interested in now, and I think it's gotten to the point where it's easy enough that if people start using it, I think they'll see the benefits of actually having a decentralized communication grid. Because this mesh, unlike everything you always hear, decentralized. Well, if it uses the internet, it's really not decentralized. Um, and if it's using someone else's infrastructure, it's not decentralized. You can deploy this mesh independent of anything else. It's decentralized. You communicate. You can technically host web services. You can do quite a bit. And it just takes a little bit to get go. So the first thing I will say you need to look into is you have to have the serial drivers, no matter what, whether or not you're going to be doing the web flash, or you're going to be doing the command line flash, or you're going to be using the app flash. You're going to need the drivers. So just make sure you get the appropriate driver for whatever version you bought. I bought the T-Beam, which is ESP32. So if we go here, it'll tell you, oh, hey, here's your Mac driver, here's your US. Now, when it comes to Linux, it's already built in. You just got to enable some things, but it'll just work for the most part. UART serial bridges are just going to be in Linux. You just need to enable it, essentially. So once you get your firmware or your serial stuff installed, then we're going to go to Flash. Now, for instance, let's just take a look. I've got the drivers, I've flashed, I've got 5 of these radios, right? And I can, sometimes the web flash will work, sometimes it won't. So let's see. You have the web-based installer, so we'll go there. We're going to go web client, new connection, serial. Because I installed the driver, it does see it. But we're having some issues here, right? So I need to flash this, and as you can see, it's not displaying things correctly. So I need to flash this radio. It's playing some stuff, right? You're gonna be playing and breaking. They do constant updates, so you're gonna get very used to this, right? So what you can do is try the web flasher. So we're gonna try that. We'll try it again. Sometimes it takes a couple. No. Okay, so now you're in a situation like I was in. I can't get it to flash. I bought this device. Maybe you're gonna, So, well, what else do you have? You've also got these Android apps, an iOS app. Everything's Bluetooth with these, right? So if it's functioning at a certain level, there are certain firmware versions that if it's old enough, like maybe you haven't touched it in years or something, you're gonna have to do this by command line. So what we can look at is the commands for command line. Okay, and it essentially all you have to do is download. So you're going to come here and you're going to look, okay, well, where do I get this stuff? It's got Linux, it's got Mac, it's got Windows, but where is it? How do I do it? Well, all you have to do is actually download the firmware. And it's going to have the utility in there. A long time ago, you used to have utility, and you had to point at all these different files because it is an ESP32 system. So you using the ESP, the utility is ESP32 flasher. It's nothing insane like that. Just needs to be started at the right point. Make sure it writes at the correct blocks, and there you go. Well, in order to do that, all you have to do is download the correct firmware. So what you would do is you can go to the GitHub, and if you see Meshtastic, they've got all this stuff here. They've got the web interface. You can see the actual Python interface for your computer that lets you control and interface the device with your computer. The Android app, of course. This is how it's the API essentially for messing with doing stuff. and then firmware. Now firmware is where you're going to want to go to get the newest firmware, older firmwares, and the script if you have to manually flash these. So when you hit firmware, everything in Meshtastic is tagged for certain releases. So you'll just go to tags, and as you see here, they'll have verified and unverified tags. Okay, so look at that. There's a new firmware verified 2 days ago. So maybe you want to play around with the new stuff. So let's go there. It even lets you know. Okay, this is a pre-release. So typically with pre-releases, if you're trying to use it as like a gateway or like an established network, you're not going to want to run the alpha. They are very much testing things, new features, but it's a great way to tinker around, play with it, get more familiar with it. You can also go to betas, which will, of course, the alpha features will have been kind of tested out a little bit, and then they should have full release versions. That's a beta. But yeah, so sometimes they'll have full. So it's kind of up to you. I'm gonna go grab the alpha, right? So we go there, and all you're gonna want to grab is this zip. Okay. Okay. Alright, now I'm going to save it there. And you're going to want to extract it to its own folder because it is got a lot of there's a lot of firmware bins in here. Okay, so now that we've got this here and we've got our radio plugged in, always make sure you have your antenna plugged in, by the way, on these. This acts as a resistor. Now, it's not guaranteed to happen, but this does cause impedance. And if you turn it on and there's something wrong or it's configured incorrectly and you don't have the antenna, you can actually fry the radio chip. It's a rare occurrence, but it does happen. So make sure you have at least an antenna plugged into these whenever you give them power. It's a bug on. I'm not quite sure exactly where, but it's happened enough to enough users that make sure you have an antenna. But we've got, as you can see here, there's there's a shell script, there's batch files, and then you've got all of these firmwares. So all you really need to do is find your firmware, and these are all the different devices that they make. So mine's the T-Beam, okay? There's an old version of the T-Beam. You're probably not going to be, I don't even think you can buy these anymore, but maybe the very, very, very first version. But it's just the T-Beam, okay? And as you can see here, there is a bin and an update bin. Now, what this is if you do bin, it erases the entire ESP32, memory, essentially, the little blocks they call it in there. It's going to erase everything, and it's going to put the default everything on there, right? If you do update, it just updates the core files, and then your settings and other things will still be there. It doesn't erase the essentially the personal storage, because there is just a tiny bit of storage on these devices. You can store, like you said, they have web browser, web server capabilities. It's ESP32. So, what you're going to want to do though is we're going to need a command prompt from this location. Okay, and the command, as you can see, if you go to their website, right here, all you have to do is say, hey, here, and then F is the file. It's like, hey, I want you to do this, I want you to do this one, and then you give it its title. So, you can always keep it like this, that way you can see what you're doing, right? And then we would just go to device, and then it'll probably there we go. It'll auto-complete for us. And that's our flag. Alright. Now if you're like, oh, what was that name again? You can come back up here. It will auto-complete a lot of stuff. And as you can see, they all start the same. And then they use a designation right after firmware. So we can start with firmware. Oh, if we did that, we don't want that, right? Let's back it up. T-beam. What happens when we do that? Oh, but double check. Remember we said that's the original one, so we don't want that one. And now we've got our file here, the bin. Now this is, like I said, it wipes everything and does a fresh install, right? So that's the one. That's what I want to do, because I'm not trying to update this one. I was playing with things and I'm just trying to get it back to going. So I'm going to use the newest alpha from 2 days ago. Alright, as you can see, it does a COM connection. If you have multiple of these, you're going to have different COM. Like I've got 5, so it'll go from COM, all mine up to 7, so it remembers, at least Windows does, whenever you plug these devices in. It's part of the driver that you install. But as you can see here, all this is actually doing is, one, figures out how it's communicating, identifies the COM port. Then it detects the chip. Hey, ESP32, which version? Oh, okay, it's this version. Gives you a little bit of information. There, you can accidentally do things, and there is possible to reset things, so it's kind of nice. Now what's it going through? Okay, it's saying, hey, start flashing. And this is where it's telling you, when you run bin like that, it starts at the beginning and goes all the way and clears out everything on here. And then after it gets done, it's going to start at a certain block there. Now you can look that up technically. There's I can't remember the manual's at, and I wrote a utility somewhere. I got it documented, but you can go in here and do the older ones. You had to do little specific sections because there was different configurations that needed to be in different areas, but now they've just put it all in one. So it's come a long way to make it easy, right? Like if the web interface doesn't work, if the apps don't work, all you need to do is download the firmware, and then you will need to make sure that certain things are installed, like the ESP32. So in general, it's pretty easy to get going. Now you do need Python. There are a couple things you're going to need. So on my system, actually we've got terminal here, because Python gets confusing for some people, right? If I type Python on mine, right, it just automatically comes up with 3, right? You might have multiple versions on yours, and you might need to do different version launchers or set up environmental variables or things like that. What I would recommend is just downloading the Python installer, and then it will ask you, do you want to add it to your environmental variables and things like that. And as long as you do that, everything in the Meshtastic world should work. And if it doesn't, there's a couple things you can check out, because there are a few things you need to install, and you use pip to install them. You need to have, when working with Meshtastic, if you're going to do certain things, especially development or things like that, you're going to need to have Meshtastic, of course, installed. And then ESP32 flasher, which is called ESP tool here. So depending on the version of Python you have installed or how you have your system configured, you might need to actually use Python 3, right? Or it just very much depends. And on Windows, you can configure that with environmental variables. So the way you can look at that is checking with, on Windows, it's really easy. I like to just use this, launch it, path browser. And this is what the default Python, when you just type Python, where it's already looking for all of these installed things, right? So if you do Windows app install based Python, as you can see there, it can generate a lot of different entries, and it depends on how you've installed things, and it can get very confusing. But if you do it from the installer, though, you're going to be getting the Windows Software Foundation. So, and this is where if you use the installer, it'll automatically add it to your path. If you don't use the installer, you just need to make sure wherever your modules are getting installed, that is included in the path, and then the tools will work. So let's check in on, there we go. Looks like it's going, and now, as we can see here, it's flashing. It's not just static anymore. Okay, so now if we go to the web utility, initial configuration, just making sure. So you can choose one. So now that it's connected here, as you can see, there's actually a thing that says, and if we go to configure, now we actually have options here, including power. So this right here alone is a game changer for Meshtastic, because I mean, originally when I got involved, I started making a very basic little UI. It doesn't work anymore for the most part, because it was for the older Meshtastic API and things like that. But it was kind of hard for a lot of people to figure out how to set certain things. So now, I mean, you can use the web browser. You can also use your phone, which is amazing. If you want, you can download the app, and when you launch it, if it's not been ever set up, if you do a clean flash and you've got Bluetooth turned on, it'll see the radio, and then it'll say connect to radio. And then you can use the app to configure it. Now what I'm doing is I'm using this, right? So you can change your Bluetooth, you can change, I need to change my region, so US, save. And this is probably the first thing you need to do, is you do need to make sure that you set your region correctly. Now, the hop limit. These LoRa, the default settings for the LoRa stuff is it kind of wants to spread the network messages, especially if you're just doing an open gateway to allow all kinds of people science projects and stuff like that to communicate. So this will say how many times a message will go through your network, and every time it goes through a radio or a node, it decreases this number. So if you start with 3, it'll only go through 3 nodes, and then it won't continue the message. So the bigger your network is, or if you've got certain things set up way, you can increase this number, but the default is 3. And this is to keep networks from being oversaturated, because duty cycle and things like that are important. There are medical devices and other things that use the same spectrum, so you can't be hogging, constantly using the spectrum. So it is important. Now the channel number, there are multiple channels you can use in with Meshtastic. The default is 0. And this right here is where you can set kind of the power settings for your Meshtastic device for how it's going to communicate. So long fast is the default. And for the most part, this is going to work for most people for just a little message communicator and things like that. Long slow, it's not as intuitive, is even further. So the faster lower it works, the shorter the distance is going to be without having more power. And you can't run power without a license, right? So long slow is even longer distance, but the messages can take a bit to get between the nodes. Very long slow. I've gotten 5 miles on mine so far. Mind you, that was going over a lake. So a good chunk of that was unobstructed. But even still, if you don't have anything blocking the airwaves above you, these, with the default antenna, they can go. The longest distance I think we've recorded with Meshtastic was 100 miles, like 166 kilometers or something like that, like 109 miles, something like that. Then you've got medium and stuff like that, short, and because under short distance you can do quite a bit. You can use these for SSH tunnels and things like that. It's pretty nice. But long fast is what most people are going to want to use, right? This is where if you know what you're doing and you can get in here, you can really tailor these things for the area you're in. You and your project. To save battery, to either not interfere with things, to get just a better, clear, signal. So these, if you're really into radio projects, this web UI alone has brought this project to where I think it's better than almost anything else. Because all of the things that you're going to want to really mess with, you can do here. I'm still working on an offline app that's going to be really basic and small and easy, that won't require a web browser and all this other stuff to work. But this is perfect for getting started because you can come in here, as you can see, these are all the countries in which you can use this device, and when you set these at the appropriate thing, it's going to set the spectrum, it's going to set the power limits, it's going to do all that. Now to remind you, there are places, even in these areas, you cannot use these. Colorado and Wyoming, the United States, parts of Wyoming. And it's not all of Colorado, it's like a certain longitude, latitude area that you're not supposed to. And I think it's for radio antenna interference. There's like satellites that do space observations. They don't want any interference. But here, as you can see, we've got channels where you can configure things like that. You can do all kinds of things with this, right? It's really interesting what you can do with your channels. You've got your map. Now this is built into the thing. So I live near Seattle area, right? And Renton area. And this is OpenStreetMaps. And this is my mesh, okay? Right, so it starts with there, and once you have this area going, or if you had multiple nodes, so maybe you get a friend to put one here, or you get a friend to put one here, then you can extend your mesh, and you can actually make these do different things in the configuration. You can actually say you want it to be a what do I want this to do? So if it's a client, it receives messages, it sends messages, it'll send its location, it looks for the location of other nodes on your mesh. If it's a muted client, it will receive messages, but you can't send with them. It doesn't broadcast, it only displays, because you can, I don't have the display set up on this one, because I use this one as a router or a gateway or just whatever. But I do have the display set up on this one. And I have a heads-up display on this one. More about that. So you can change, you can very much set these to do different things. Router, of course, this is actually how you make it into a gateway, sort of. So it's just an MTQ. I'm stuttering. Slow down. Okay. So you can do quite a bit with these, and one of these is, like I keep saying, gateway, and it's like, okay, what am I talking about? Well, there's just a general sensor network that you can open up to allow anybody that is running a little science project or something like that. You can set this up as a gateway to allow other lower devices to connect to the internet, and then maybe that data gets pushed to a server they got somewhere, right? So Meshtastic has a public gateway that you can use, and they actually have that's an information set up right here. Let's see. Like I said, this website, come here for docs, it tells you everything you would really want to know about setting it up. Let's see. Trying to remember where. There we go. So, Meshtastic itself has an MQTT. I have to slow down. MQTT gateway that you can use, a default one, right? It's already available, and it's great for if you're making a weather station or whatever your science project, because this has GPIO. Okay, you can literally do anything you want to do with this with the ESP32. Okay. There's already some modules that users have made because it's so common. Actually, if you look right here, there's a thing called module config. Okay, and these are things that users requested so much that we started, because Meshtastic is a modular system, you can create little plugins that you can turn on and off. And certain ones were incorporated into the project because they're useful. So one of them is this right here. So you can enable this to be a gateway for any other LoRa scientific project, or for your own mesh, right? So maybe you want to communicate with stuff. It's really up to you. So once you get going with it, you can, as you can see right here, this is all basic stuff. You can then use this to, like I said, you could have a weather station. That's actually a couple things, like serial here. It'll just do serial. You can wire that up if you want. It's got, this is actually MC Hamster wrote this one. It's incredibly useful for just testing your power set. Like if you were back when we were really figuring things out, it automatically creates a CSV file on the device. So you just set up a base station and then you walk around, and then you could pull that CSV file, and it would tell you whether it was the range and success. It was actually really useful. You can do all kinds of things. We're also working, you will see here, it is push to talk. Everyone wants it to happen. It can happen. Mind you, there are some developers on here. MC Hamster is one of them. These people worked in telecommunications in the 80s. They can do a lot with 32 kilobits. They can do a lot with less than 32 kilobits. We've done some impressive things. It's just not real time. So LoRa just doesn't. It can, but it just really, it's not meant for that. But push to talk is something that is being worked on. People really wanted it, so it's a plugin, right? You can use it to send audio messages, though, recordings and things. Yeah, I mean, like I said, it's an incredibly versatile project that allows you to do whatever you really want, and it's now gotten to the point where it's really easy to set these things up, and it's really easy to get your project going. And as far as the tools here, This website does a pretty good job on how to get going. You just really need to have Python installed. And you, like I said, showed you just go to the website, you download the firmware, you use their pre-made bat file or shell script, whatever OS you're using, and it will flash the device. And once you have the device flashed, you can either use your computer with the web browser, iOS, Android, or if you want to tinker, you can do something like what I'm doing. A long time ago, I had a utility I wrote for this, but like I said, it's no longer useful. So now I'm getting back to making something useful again. But I really do recommend you check out Meshtastic. The community is great. There's quite a bit going on. The documentation has really come a long way. And overall, it's just a really fun. Like, see this right here. This is for the ham radio operators. You can do 3-watt output. There's different versions for different projects that people wanted to make. Pretty neat. Tiny little handheld ones. And different versions of different things. It's pretty interesting. This new one, I believe, is the new one. So that'll be interesting. Antennas. I will say a lot of people, they want to go get these big antennas, all this stuff. There's been a lot of testing done, and the longest range was achieved with the stock antenna sent with the device when you buy it. You can make a better one, but that's a hobby in and of itself. Technically, I mean, the longest Meshtastic setting with a successful Meshtastic established mesh was 109. So that's doing what it's supposed to do as a mesh. But a point-to-point, I believe, it was like 290, almost 300 kilometers in Europe. He had a gateway radio set up with his local radio community on top of a tower, and he, I believe it was France. I believe it was either France or England, but they were able to establish a connection to the gateway. The range is just unreal on these things. And like I said, that's without being a radio operator. If you're a radio operator, you can do some really, really cool things. There's some people here, the ham guys, that started getting involved with these. Because ham can already do much more. I mean, you can do data and all that stuff. But as far as having a really cool sensor network for science projects, that's where it's really cool. You can communicate with, there are lower satellites, you know, there's actually a goal, maybe, there are people we've been talking about getting the money together to get a Meshtastic nanocube or whatever up in outer space. That way you can periodically connect to, you know, a global satellite mesh, because it'll do it. It's pretty fun. It's pretty fun. So yeah, give it a whirl. It's one of the best little lower projects I think out there, and it's definitely an off-grid communication. Encryption is already built in. If you're paranoid, you could just pre-encrypt the message you're going to put on it with PGP anyway, but it does have encryption built in. If someone got a hold of the device, they can extract the key, of course, though. It is a ESP30. It's not magic. And if someone... so I don't want people to think that this is like a super secret comms thing. I mean, it can be made to be that way, but it's not developed that way. It's more to make your own mesh and have fun. What it can do by default is it does deadheading and GPS. So I want to get a better GPS antenna, but this one, you know, GPS antenna, this screen I'll go ahead and turn this one on. So when you attach the screen, one of the benefits of this is whenever a node joins the mesh, it knows, okay, once the node pulls its location, which can take a little bit, but once it pulls its location and it knows where it's at, it will broadcast its location to all the other nodes on the mesh, right? You can even, if it's going to be a static one, you can say battery and duty cycle and all that stuff. You can just turn it off and say, hey, I'm always right here. But the cool thing about this is, so say you and your buddy, right, you're going to go skydiving or paragliding or some kind of extreme sport that's off-grid. There's no cell phone. Radios work and don't work because if you get in a ravine, that radio signal's not getting out of the ravine type stuff. So with these, what you can do is, what I've done is I'll have one in my car, right? It's kind of like the base station. And then me and my buddy will have one. And we can go do whatever. Now, these nodes will know where the base station one is the car, right? So if we get separated, it'll always know that that's a static location. I can check this and be like, oh, it gives you deadheading. It'll say, 1,000 meters this direction, right? And then from there, you hopefully have the skills to get back, right? But it knows where the other node is last checked in too. So as long as they're communicating, they're saying, hey, I'm here, I'm here, I'm here. So if you get separated, what you can do is, and then we've done this for testing, is you just get to a high enough area, will get free of, if you're like in a mountainous area or forest or something, you get somewhere where you can get some clear line of sight, so this can get out, because this will broadcast out and above. It's a Omni. Well, this antenna is a little different, but it's just a big old bubble, like a standard, omnidirectional antenna. And if both of you can do that, well, then it'll sync. Oh, hey, the node just checked in. He's over there. And that's actually what prompted me to make this. And this is the first version of a helmet that I was going to make for wilderness first responders. Now, they don't really use these helmets. This is just a helmet I got with an idea. But this allows you to have protection when you're doing stuff and get information about nodes. So you could, my idea was, and this is the wrong helmet, I'm going to get a different helmet. They don't use these helmets. I learned a lot about that for the firefighters and stuff since then. But my idea was, if these firefighters or wilderness first responders have these radios on them, and there's a flare-up or they get separated, well, as long as they can get to an area where it'll check in with the other nodes, they can get back. So you could be in an area where you have no clue. And because they bring people from like Argentina, all over the world when there's a big fire in the Pacific Northwest, and vice versa, when there's a big fire in South America or something like that. We send guys, they have no clue where they're at. Okay, they're not familiar with it. They might have a topo, they might not. Some of them are volunteers, some of them are inmates. So you're just like, what do you do when there's a flare-up? And my idea was, well, as long as they have these nodes, these radios, it can tell them with deadheading where base station is, where other nodes are. So if there's a flare-up and they all just run, which is what you're going to do, you're just going to try to get away from the fire, right? There's not much you can do if there's a big flare-up. So they'll run, and I've talked to enough of them. I say that's what happens. You run, and then you might get lost, or you might be running in the wrong direction. And it'd be nice to know not to go that direction, right? And so I figured, okay, these nodes, you can scatter them throughout the forest and temperature-proofed devices with sensors, because it's got a sensor capability that will detect flare-ups. It'll detect fire. It'll alert the firefighters, saying, hey, there's a flare-up coming your way. Get out of there. Run. And then they can run, and they can have these radios, and when everything gets to where it's safe, they're not having to be like, worried about stuff. Then they can just calm down, let the system check in, and at the very least, it knows where base camp is, and they can be like, okay, I need to get back this way. But it would also check in with the other nodes. So say other guys started running. So then you could just calmly wait. You could wait for all the other nodes to check in. If they didn't check in, well, you can go start looking for people. And maybe they've been immobilized, but they're not down and out, or maybe they're unconscious or whatever it is. And this radio, once it establishes connection, it'll say, "Hey, the node's over here. Come over here." So I think it's got some great uses for public service as far as fighting forest firefighters and wilderness first responders in areas that don't have established radio communication. Not everywhere is nice enough to, like the Cascades and there's Snoqualmie and stuff. Yeah, they got good radios and they've got radio towers established. But there are even still some ravines in there where it's hit or miss whether or not that radio is going to work. Whereas something like this could easily be deployed, and I've got another whole idea on how to deploy an instantaneous mesh that can cover an entire mountain range pretty much, and not worry about limited line of sight, but that's a whole other thing. Once again, my name is Bob, and thank you for watching my video about Meshtastic. And if you have any questions, leave a comment. Have a good day.